Suppose a plus b plus c equals to pi radians. We need to show that the following trig identity is true. Okay, now this given trig identity, this is a conditional trig identity. The reasoning behind this is, if we consider the trig identity sine squared theta plus cosine squared theta equals to 1, it's called an identity for a reason, because it is going to be true for any values of theta that we choose. However, for our case, it's going to be conditional trig identity, because we cannot choose any random values of a, b and c. We have to choose the value of a, b and c such that the sum always equals to pi radians. Okay, anyways, what we'll do, we'll not try to find out the value of a, b and c here. We'll only try to prove that the given identity is true. So we'll start a proof from the left hand side. So on the left hand side, we have cosine of the half angle a over 2 added to cosine of the half angle b over 2, and then we have cosine of the half angle c over 2. We're going to combine the first and the second term, because here we can use the identity. If we have cosine of c added to cosine of angle d, that's going to be given as 2 times the product of cosine of c plus d divided by 2 multiplied to cosine of c minus d divided by 2. Fine. Okay, so a sum will become the product of two cosine functions. So we have 2 times cosine of the angle a plus b. However, we have to be careful. We will get a plus b over 4, not over 2. Similarly, we get cosine of the angle a minus b divided by 4 added to, so here we have cosine of c over 2. Now we're going to change cosine of c over 2. We're going to use the fact that since a plus b plus c equals to pi, then c is equals to pi minus a plus b. Now what we'll do, we're going to divide both sides with 2 such that we get c over 2. This is going to be equals to pi over 2 minus a plus b divided by 2. Now let's take the cosine function on both sides, since we need cosine of c over 2. So cosine of c over 2, that is going to be equals to cosine of the angle pi over 2 minus a plus b divided by 2. So now we know that cosine of pi over 2 minus the angle theta, this is simply equals to sine theta. Our theta here is denoted by a plus b over 2. So we get sine of the angle half angle a plus b over 2, meaning cosine c over 2, this is going to be the same as sine of a plus b over 2, provided a plus b plus c equals to pi. So what we'll do, we'll replace cosine of c over 2 with sine of the angle a plus b over 2. Okay, now the reason why we had to convert to sine of a plus b plus 2, because here we will be applying the half angle formula for sine. We know that if we have sine of the angle theta, that is simply given by 2 times sine of the angle theta over 2 multiplied to cosine of the angle theta over 2. We're going to use this fact to expand sine of a plus b over 2. So we will now get, so the first term remains the same. We have 2 times cosine of a plus b over 2 multiplied to cosine of a minus b over 4. Oh, my mistake, this is not 2, this is 4. Now we're going to use the half angle formula to expand sine of a plus b over 2. So this is going to give us 2 times sine of, so we have to take half of a plus b over 2. So that's going to give us a plus b over 4. Then to it, we're going to multiply cosine of half of a plus b over 2. So this will be a plus b over 4. Now, because of this transformation, we can see that we can take 2 times cosine of a plus b over 4 as a common factor from each of the 2 terms. Now let's do that. We get 2 times cosine of the angle a plus b divided by 4. So this is going to get multiplied to cosine of the angle a minus b divided by 4 added to sine of the angle a plus b over 4. Now if we compare this result with the right hand side, although we are quite not there yet, but we can see that we have the factor 2 from 4, and we have obtained cosine of a plus b over 4. So we now need to add the 2 trig function within the parentheses to get the rest of the expression. Okay, so here the problem is we cannot straight away add the 2 trig functions within the parentheses, because one is a cosine function and other is the sine function. So in order to add this, both of them have to be either cosine function or both of them have to be either sine function. However, what we can do, we can use the facts. So let's write down the terms that are not changing here. We have 2 times cosine of a plus b over 4. This is going to get multiplied to. So what we will do, we'll keep cosine of a minus b over 4 as it is. We will try to change sine of a plus b over 4 to a cosine function. Now how shall we do that? We know that if we have sine of some angle theta, this is the same as cosine of pi over 2 minus theta. Now in our case, what is theta? Theta is a plus b over 4. That means sine of a plus b over 4. This can be also expressed as cosine of pi over 2 minus a plus b over 4. Let's combine the two angles within the parentheses. So we have cosine of, so we'll get 2 pi minus a minus b divided by 4. So here we're going to transform sine of a plus b over 4 to cosine of 2 pi minus a minus b over 4. So let's use it. We have positive cosine of the angle 2 pi minus a minus b divided by 4. Okay, now what we have is the sum of the cosine function. So here what we can do, we can use the formula for adding two cosine function, which is going to give us the product of two cosine function. So let's use it. Now we are going to get, so we have 2 times cosine of the angle a plus b divided by 4. So that stays unchanged. Now adding the two cosine functions gives us the factor 2. So we have 2 times cosine of, now what we'll do, we're going to consider this to be angle C. So we have a minus b over 4 added to angle D. So D here is represented by 2 pi minus a minus b divided by 4 whole divided by 2 multiplied to cosine of the angle. Now we have C minus D. So that we'll do a minus b over 4 minus 2 pi minus a minus b divided by 4 whole divided by 2. So we get 2 times 2. This gets multiplied to give us the factor 4. We have 4 times cosine of the angle a plus b divided by 4 multiplied to, now what we have is cosine of, so we're going to combine this expression. So that is going to give us pi minus b divided by 4 multiplied to cosine of the angle. Now when we compute these terms within the parentheses, so that's going to simplify and give us pi minus a divided by 4. Fine. Now what we have is 4 times cosine of the angle a plus b divided by 4 multiplied to cosine of, now pi minus b, we can change it to a plus c. Angle a plus c divided by 4, and cosine of pi minus a, that can be changed to b plus c divided by 4. So here we are using the condition, that means a plus b plus c, that's equals to pi. So pi minus b is simply the sum of the angles a and c, whereas pi minus a is simply the sum of the angles b and c, and this is exactly the expression on the right hand side. So here we have successfully showed that the left hand side equals the right hand side. We have, meaning in other words, we have verified the given conditional trig identity.